You know that feeling, right? When you get a new computer and everything is just instant. It's snappy, it's responsive. We all want that speed. But the magic behind it isn't just about a faster processor. A huge piece of that puzzle is actually how your computer gets to its data. So today, we're going to pull back the curtain on the technology that made it all happen.
So let's start with that big question. Why did our computers suddenly get so ridiculously fast? It wasn't just one single thing, of course, but a really crucial piece of the puzzle was a total revolution in how our storage talks to the rest of the machine. All right, so here's our game plan. First, we're going to look at the problem, what we call the old storage bottleneck. Then, we'll introduce the hero of the story, NVMe, this new protocol. We'll check out how it uses something called the PCIe superhighway to do its thing, break down what the advantages are for you, and then look ahead to why this tech is building a future that feels instant. To really get why NVMe is such a big deal, we have to go back and understand the problem it was built to solve. For the longest time, our computers were hitting this invisible wall, a speed limit that had nothing to do with the CPU, but with something way more basic. I bet most of us remember the jump from those old, clunky, spinning hard drives to the first solid-state drives. I mean, the difference was night and day. But here's the thing, there was a catch. Even with these brand new, super fast SSDs, we weren't actually getting all the speed they were capable of. Something was holding them back. And this slide is the heart of the issue. The communication methods we were using, protocols like SATA, they were designed decades ago for slow, mechanical, spinning disks. It's like we built a Formula One race car, our SSD, but then we forced it to drive on a winding, bumpy country road. The hardware was ready to fly, but the language it was forced to speak was just old and slow. So if the old language was the problem, what's the solution? Well, you've got to create a new one, right? A language built from the ground up specifically for the incredible speed of modern flash storage. And that is where NVMe comes in. Now, this is a really important point to get. NVMe is not a type of drive. It's the protocol. It's the language the drive uses to talk to the rest of the computer. The name itself, Non-Volatile Memory Express, pretty much says it all. It's an express lane for your storage to talk directly to the brain of the computer, the CPU. And this didn't just happen by accident. As you can see on this timeline, back around 2011, a whole bunch of smart IT professionals saw this bottleneck happening, and they got together to design a solution. They literally created NVMe for the sole purpose of smashing through that old speed limit and unlocking what flash storage could really do. Okay, so we've got a new, faster language. Awesome. But how does that actually translate into an insane speed boost? Well, the secret is in the physical route it takes to get from the storage to the processor. Let's go back to that car analogy. That old SATA bus was the slow country road. NVMe just completely bypasses it. Instead, it hooks into the PCI bus. And you can think of the PCI bus as a massive, multi-lane superhighway that goes directly to the CPU. No stop signs, no detours, just a straight shot. That direct connection is everything. And just how fast is that superhighway? Well, the PCIe bus that NVMe uses can hit speeds up to 20 gigabits per second. To give you some context, that is so fast you could download a full-length high-def movie in under 2 seconds. That's why loading a huge video game or scrubbing through a 4K video timeline feels so incredibly smooth. The process itself is just beautifully efficient. Instead of a long, drawn-out conversation, the computer basically just sends a quick to-do list of data it needs. The NVMe drive grabs that list, executes all the commands at once, and just fires back a quick done, done, done. It's an incredibly streamlined process that cuts out all the wasted time. So we've covered the what's and the how. Now let's get to the most important part, right? What does all this techie stuff actually mean for you and the devices you use every day? On a technical level, it really boils down to these things. High throughput, that just means it can move a lot more data at once. Extremely low latency, that means there's almost zero delay between when you ask for something and when you get it. And what's really cool is that it's scalable and future-proof, which means it was designed to get even faster as other tech improves. And this is where it all clicks into place. These are the advantages you can actually feel. We're talking about that crazy fast performance. A game that used to take a minute to load now just pops up in seconds. And it works with everything, Windows, Mac OS, Linux, you name it. Because it talks directly to the CPU and was built only for SSDs, it just flat out eliminates those old bottlenecks we were talking about earlier.
Now, the story of NVMe gets even bigger because its impact goes way beyond just making your laptop faster. Its ability to handle massive amounts of data in the blink of an eye is actually becoming a cornerstone for the future of technology.
I mean, think about it. Fields like artificial intelligence, the Internet of Things, machine learning, what do they all depend on? Analyzing enormous data sets in real time. NVMe speed is what makes that possible on a massive scale. It's the engine that's powering this next wave of innovation because it gets data access out of the way. And it's no surprise that this is becoming the consensus. This isn't just some niche technology for enthusiasts. It is the future of storage. The speed, the efficiency, the whole design. It means NVMe is becoming the standard for pretty much everything, from our phones to gigantic data centers.
So we solved the storage bottleneck and we unlocked this incredible new era of speed. But that just leaves us with a really fascinating question, doesn't it? As data becomes more and more central to everything we do and our technology gets even more powerful, what's the next hidden speed limit we're going to have to find and smash through?